I'm studying Pharaohs ants, which are a very small ant. They're just 2 millimetres long, and they're really good at foraging. They scavenge and they live in places like student accommodation, where there's plenty of food to scavenge on, and they're really successful at organising themselves. So it's been known for a long time that ants lay down chemicals when they find food, and that the other ants follow these trails, these pheromone trails, to the food. But what we've found out recently is that if ants go to an area and there isn't any food there, then when they come back, they lay down a negative signal, a signal which says to the other ants, there's no food here, don't go this way. So we call this the no entry signal. And then the other ants don't waste their time going down that area where there isn't any food, but instead go and search other areas where there might be food, or follow positive pheromone trails that lead them straight to food.
We're interested in ants because they're examples of complex systems, social systems, and we're using these insights to try and understand how complex systems can be designed. We're applying some of the ideas in other areas of biology, but also in technology. When you have a disaster, the mobile phone system falls apart, mainly because it's controlled centrally. So the idea is to look at the way ants work, because they're not controlled centrally. It's a self-organising complex system which is very robust and adaptable and works, and it's evolved over millions of years. Are there insights there about how those sort of systems work that can be applied in other areas?
These pheromone trails that they produce are an excellent way of finding the shortest path. The ants use them to find the shortest path to the food. But we might be able to use them in our systems to find the shortest paths through computer networks, to send information around those networks in the most efficient way.
So we took those sort of insights and we started thinking about other things. So, for example, how wounds heal in tissue. It's a completely different situation, but here, instead of ants, you've got cells. No one's telling each cell what to do, but they're a society. They communicate with each other, and during the process of doing this, they form skin, tissue. So we made some computer simulations of this and tried to understand what's going on. One big problem is that some wounds don't heal, so this is very unpleasant for a number of people. And we investigated these and discovered that in the computer simulation, the role of stem cells was very important.